Otherwise, it's still. I can tell I'm still a bit nasally, but otherwise, I'm not doing too bad. All right, my vMix program tells me that the stream is up and running again. So if you went looking for my Discord stream, it should be there, and the YouTube stream should also be there as well. I might just knock my level down a bit. Hello. Might be just a bit too much audio there on 80 meters perhaps. 1, 2, 3, 4. All right, hopefully things will be okay for the next hour at least. All right, it's being the first of the month. Well, as in the first beginning of a new month, April. We always kick off with the sky notes from Tanya Hill, the resident astronomer at the Science Works Planetarium, who every month sends out a sky notes. So we'll get. Oh, before we do, of course, we must mention who the sponsor is for this broadcast on a Friday night that I do it for, and that is the Astronomical Society of Victoria. The ASV is a non-for-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the society has grown to over 1,000 members. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our two metropolitan locations, the Morley Community Village and the Melbourne Observatory. And we host monthly Astro Talks at the Herbarium. If not, it'll be on a Zoom presentation like this month's presentation will be. The Society's library is also located at the Melbourne Observatory and is open during Astro Talks. For over 50 years, the ASV has played a major role in the care of buildings at the facilities at Melbourne Observatory. Our members conduct regular astronomy for the people gatherings. Sidewalk astronomy is another term for that, bringing telescopes and astronomy to Melbourne parks and schools. It's suggested that you check the online calendar on the ASV webpage for any details about when there are up-and-coming gatherings. The ASV is currently involved in a number of major projects. We are involved in the restoration of the Great Melbourne Telescope and are also currently working on the installation of a series of remote telescopes at our dark sky site, which once complete will be accessible to members for their use. Most of those domes are now operational. Thanks to the generous donation from one of the most long-standing and respected members, the Leon Mao Dark Sky site, located north of Melbourne, has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope, and a wheelchair-accessible 16-inch telescope at the Leon Mao Dark Sky site, and makes use of the existing telescopes at the Melbourne Observatory during some section meetings and our monthly meetings at the observatory. Members' night held. Our members' night held once a month at the observatory is what I'm trying to say. There's also a fully steerable 8.5 metre radio telescope, which is maintained and controlled by the radio astronomy section. Members of the ASV can get involved with that through that section. A annual yearbook is also supplied to members, as well as a bi-monthly newsletter called Crux, which all members are welcome to contribute to. The ASV logo shows the Southern Cross and pointer stars, and it has a Latin motto, which when once translated stands or means "this way to the stars." The ASV is governed by a set of rules which should be read before applying for membership. The document may be downloaded by clicking here. Any person or organisation with an interest in astronomy may apply for membership of the society. So that's it in a nutshell. And but more information from the ASV can be found from the homepage at www.asv.org.au. There are also a number of sections that make up the various activity groups within the ASV in alphabetical order: astrophotography, club section, comet and meteor section, computing section, cosmology and astrophysics, deep sky, historical section, instrument making, juniors, lunar and planetary, new astronomers group, radio astronomy, solar astronomy, space exploration. So any of those sections that sound of any interest to you, by all means, visit the ASV website, look under the sections tab. All those sections that I just read out there are separate pages. There's a link to a separate page, and more information can be found there. You can contact details for the section director, and you're more than likely be welcome to pop in as a visitor, and the section director will introduce you to the ASV and all that. All right. Now, coming up, let me just bring up the calendar. Oh, yes, I've got a slide for this too. I'll bring up the slide. Where is the slide? There it is. Stand by. Just get the article ready here. As the slide says, just bring the page down so I can read this. The Astro Talk, slated for the 9th of April at 8 o'clock. It's a Zoom only meeting, but I would imagine that it should go out on YouTube and the Facebook page. Yep, it does, and Twitch. Astro Talk, Indigenous Astronomical Knowledge Guide, is what this month's Astro Talk is going to be about. How can Indigenous Astronomical Knowledge guide modern astrophysics? Dwayne Hampshire, Associate Professor of Cultural Astronomy, School of Physics, University of Melbourne. As we learn more and more about ancient ways of knowing and understanding the world around us from an Indigenous perspective, it is increasingly apparent that typical views of the Aboriginal and Torres Strait Island knowledge are grossly incomplete and misunderstood. Indigenous Australians have been observing the cosmos for millennia, developing complex systems of knowledge about a wide range of astronomical objects and phenomena. As elders share traditional knowledge, the astrophysics community is taking note and realizing that there is much we can learn from thousands of years of traditional knowledge, which can guide telescopic observations and practices in astrophysics. How does this work? And what can we all learn from Indigenous astronomy? So the event is streamed on the event will be streamed on the ASV's YouTube channel and on the Facebook page, the ASV's Facebook page. So you can catch up with it there. I'll also be picking it up off YouTube for replay over Melbourne television repeater on that Wednesday night, 9th of April. So it should be an interesting little presentation by, how do you pronounce that name? Dwayne Hampshire, anyway. Dwani. All right, so that's coming up on the 9th of April. Astro Talk. Okay, now next is, where am I here? Done that, yes. Okay, Sky Notes. Let's go straight across to Sky Notes for April 2025. And something about Lucy to visit its third space rock. Having already flown by 2 other asteroids, NASA's Lucy probe is set to pass by another this month, asteroid 52246, or the Donald Johanson is the name given to it, which is almost 5 kilometers in size and likely ovoid or elongated. Ovoid or elongated, which I do have a picture here. Actually, I think we got it. Yes, this is what the article is referring to. Again, you can view the vision on my YouTube stream, VK3CSJ. Just look for the live indicator on my YouTube channel, VK3CSJ. And also on Discord. We're broadcasting on my HD channel Discord, which, if I look, there are 5 people there, in fact. G'day Andrew, Bruce, and 4 actually. Andrew, Bruce, Mitch, and Steve. G'day Steve. Alright, back to the article. Johansen, Donald Johansen. So it's the very oval green looking object in this particular mosaic of images, collection of pictures. What this picture is showing is actually the comparisons of bodies against an estimate of Lucy's target this month. Main belt asteroid Dinkenish and Steins were visited by Lucy in 2023, with near-Earth asteroid Bennu by NASA's OSIRIS-REx in 2020, and Rayg by JAXA's Haibashua 2 in 2019. The latter 2 probes returned surface samples to Earth. Getting back to the article, it seems to have arisen from a break up a large body perhaps 150 million years ago in the inner main belt that resulted in the post-collision of the Oregon group of small orbits, or within similar orbits, they say here. Lucy's mission is to investigate up to a dozen asteroids over a dozen years, including some of the Trojans that orbit in groups that lead and trail Jupiter. As Lucy's principal investigator, Hal Levison, has said, these relics are effectively fossils of the planet formation process, holding vital clues to deciphering the history of our solar system. And there's a little graphic here as well. That guy there. This illustration on screen now is of Lucy asteroid flyby. Its circular solar panels provide enough power for its long-duration interplanetary asteroid hopping mission, being well within Jupiter's distance from the Sun. Unlike long-duration probes operating in the outer solar system, or rovers on Mars that require onboard radiothermal isotope power generators. Oh, I see. So the Lucy mission, investigating ancient fossil asteroids, is named after the female hominid Australopithecus afanis. Australopithecus afanis, whose fossil remains were discovered in Ethiopia in 1974, and the mission upcoming target after the fossils co-discover a paleoanthropologist, Donald Johansen. There it is. Now, the next graphic I've got here is a image. It's a GIF image showing various orbits. Oops, there we go. And this is what this is showing is the clear animation depicts the orbits of Lucy, which is the purple orbit, Earth, which is the blue orbit, asteroid Donald Johanson, which is the red orbit, and 3 others from 2021 to 2033. As can be seen, bodies in elliptical orbits, whether a planet or an asteroid, move faster than closer to the sun and slower when further out. So I'll let you guys just stare at that for a while. But Lucy is the purple orbit, Earth is blue, the asteroid Donald Johanson is the red, and I think that's about it really in that description. Okay, so on the website, the Science Works or Science Notes website, there's a link to explore more on the Lucy mission and the Lucy spacecraft. So have a look at that if you are interested in that. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with a regular Friday night broadcast. We're just presenting the Sky Notes for April. Melbourne Sun Times. Now, be aware that this weekend is the end of daylight saving. On Sunday, the 6th of April, you're turning your clocks backward by 1 hour. So we get our extra bit of sunlight back in the morning. Thank goodness for that. So on Tuesday, the 1st, sunrise was at 7:33, setting at 7:13. But come Friday, the 11th, sunrise will be now at 6:24 and setting at 5:58. So we lose our bit of daylight in the evening. Frankly, I don't know why they just ignore daylight saving and just keep it as it is, as per normal, really. But I'm not really fussed. Then on Monday the 21st, sunrise will be at 6:51, setting at 5:45. By the end of the month, Wednesday the 30th, sunrise will be at 7 a.m. and setting at 5:34 p.m. Moon phases. There's a first quarter happening on Saturday the 5th, tomorrow. There'll be a full moon on Sunday the 13th, third quarter on Monday the 21st, and then there'll be a new moon on Monday the 28th by the end of the month. Lunar perigee closest to the Earth is Monday the 28th at 357,118 kilometres. Then on Monday let me have a look at this. They've got the same date. Oh, it's a little typo going on here, ladies and gents. They got the same date. Definitely the same date written twice here. You can't have the moon closest to the Earth and furthest from the Earth at the same time. That doesn't work. I'm going to have to send off Tanya. She must have gone off for a tea break. It says that lunar perigee is Monday the 28th at 357 kilometres, and then the lunar apogee furthest from the Earth is also on Monday the 28th at 406,295 kilometres. So I'm going to have to work out which is the correct date there. I'll let you all know that important information next Friday. The planets. What's happening with the planets? Mercury. Mercury is visible in the early dawn light in the east before fading by 6 a.m. It will appear a little later each morning as the month progresses. Venus has just passed in front of the Sun, what they refer to as the inferior solar conjunction, but can be seen from 4 a.m. in the east, after which it will fade from view by 6:30 a.m. Mars is an evening object from 6:30 p.m. seen in the north at dusk. It will move across the northern sky before setting around 10:30 p.m. in the northwest. Jupiter is soon to move behind the Sun for its solar conjunction, but is still visible this month from 6 p.m. in the northwest before setting by 4:40 p.m. Saturn, just emerging from solar conjunction, is visible in the east around 4:20 a.m. before fading in the dawn light by 6 a.m. So it's Saturn. I noticed that the other morning heading out for work, looking due east, there was a distinctive bright object in the eastern sky, and I was wondering which planet that was. So it is Saturn that sits above the horizon. Yeah, so that's what I saw. Saturn. Meteors. April's main shower, the Lyrids, is centered near the bright star Vega, low in the north at 3 a.m. It is active from the 16th to the 20th, peaking on the 22nd to 23rd. Better placed is the Pi Pupids, associated with Comet Rig Stigerup, whatever that is, which peaks on the 24th, centered low in the southwest near Canopus in Carina. So the Lyrids are the meteors for this month. So for those chasing meteor scatter reports, I'd be looking active around about the 22nd to the 23rd. Yeah. Stars and constellations. Looking towards the south, the Southern Cross can be found on its side in the southeast with the two pointers below. To the right of the cross is the southern western sky. Or to the right of the cross in the southern western sky is the star Canopus, the second brightest star in the night sky. Low in the south is Achernar, the head of the river Arundinus, and Achernar never sets in Melbourne and is called a circumpolar star as it moves through a half circle around the south celestial pole during the night as Earth rotates on its axis. In the north to southwest, if a dark location, you can see the large and small clouds of Magellan, which are two small neighbouring galaxies to our own Milky Way. They appear as irregular fuzzy patches isolated from the broad band of stars that runs across the sky, which is our edge-on view of our own galaxy. In less light-polluted skies, you can also see in the main Milky Way several dark regions that are vast clouds of dust. Whilst we may see a few foreground stars, the dark areas behind obscure our view of more distant stars of our galaxy. Alright, I'll change the image there because I think you're all sick and tired of looking at that image. I think you've studied it pretty well. Alright. Looking to the west, if we turn our chairs to the west, we've got Orion the Hunter. He's in the west, lying almost on its side with the red giant star Betelgeuse as one of its shoulders. The three bright stars that form an obvious line are El-Nitik, El-Nilam and Mintaka. I can never pronounce Latin words. They mark this belt and also conveniently the base of the local Sulspan asterism. The handle of the Sulspan is Orion's sword, which hangs from his belt. Continuing the belt stars above and a little to the right, we see Sirius, the brightest star in the night sky, and principal star to Canis Major, which is one of Orion's hunting dogs. Below Sirius is the northwest. In the northwest is Procyon, which marks the position of his lesser or smaller dog Canis Minor. Below Orion and drawing closer to the horizon during the month is Hyades, or Hades, or Hades, an open group of stars that form a sideways wedge or V. This is the triangular head of Taurus the Bull, with his angry eye as the red giant star Aldebaran on the corner. Looking towards the north, you've got upside down from our southern hemisphere perspective is Leo the Lion. This constellation is easily recognisable by the hook shape or inverted backwards question mark of stars that forms the mane on the lion's head and shoulders, if you can imagine that. To the left of Leo and close together are the two bright stars Castor and Pollux, the principal stars in the constellation of Gemini, the twins, which appears upside down as well from southern latitudes. Turning our chair to the east, later this month and into May, the spectacular constellation of Scorpius will begin its return to our evening skies. This is one of the largest constellations, and when it appears low in the east, you can easily identify to the left its long curving tail leading to its body containing the red giant star Antares, marking its heart, and to the right its pinches reaching outward. Okay, the International Space Station orbits every 90 minutes at an average distance of 400 kilometres above the Earth. There's just a small handful of really bright passes this month. Friday the 4th of April, there was a pass at 6:55 a.m. to 7:02 a.m. On Monday the 7th of April, there's a passing at 5:08 a.m. to 5:11 a.m. from the north-northwest to the northeast. In the evening on Saturday the 12th, there's a passing at 12:13. On Saturday the 12th, there's a passing at 7:13 p.m. to 7:15 p.m. North-northwest to east. And then on Tuesday the 15th, there's a passing at 6:20 p.m. to 6:27 p.m. coming in from the northwest to the southeast. Those orbits or passings over this part of Victoria, you can find more details and more passings on heavensabove.com. Heavens Above is a great little website. It's a planetarium on the website, more or less. It gives you passes for just about every celestial object and satellite, and particularly amateur satellites. So visit heavensabove.com if you haven't before, and be sure to put your location in the settings so that you can get accurate passing times for whatever it is you're looking for. Now, I'm just going to go through a handful of these dates, not all of them, but on this day, on the 1st of April 1948, was Alpha, Beth and Gamow published their famous paper on the hot Big Bang. Alpha, Beth and Gamow published their famous paper on the hot Big Bang. All right. On the 2nd of April 1845, Fitzhugh and Foucault, must have been French, take the first photograph of the Sun. On the 3rd of April 1966, Luna 10 became the first spacecraft to orbit the Moon. On the 6th of April 1973, Pioneer 11 probe launched to Jupiter and Saturn. On the 8th of April 1732, the birth of David Rittenhouse, who determined Earth-Sun distance of 150 million kilometres. It was 1732. On the 9th of April 1959, NASA's first cohort of astronauts, the Mercury 7, are announced. On the 11th of April 1905, Einstein's special theory of relativity is published. Also on the 11th of April 1970, Apollo 13 was launched on its ill-fated mission. Then on the 12th of April 1633, Galileo's trial by the Catholic Inquisition on the question of a sun-centered solar system begins in Rome, 1633. Also on the 12th of April 1961, Yuri Gagarin, USSR, became the first human in space orbiting Earth for 108 minutes in the Vostok 1 spacecraft. And also on the 12th of April 1981, Columbia was the first space shuttle to be launched. And one more, on the 14th of April 1629, birth of Christian Huygens, who explained Saturn's rings and discovered its largest moon, Titan. All right, there's a bunch of other dates, but we'll leave that to another time. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. With the regular Friday night broadcast, and I think everything is still working here. Yep, streams are still streaming. Now, this is an interesting article. This was featured on the WA broadcast last Sunday, but if I if I hadn't have had a sickie last Friday, I would have mentioned this as one of the reports, but I wasn't around. So anyway, the Dwingeloo Radio Telescope, DWINGELOO, Dwingeloo Radio Telescope. The Dwingeloo Radio Telescope, or DRT, is a Dutch radio telescope near the village of Dwingeloo, on the edge of the Dwingeloolische Heide. It's German. It's a national park. The DRT has discovered, among other things, two small galaxies near the Milky Way that have been given the names Dwingeloo 1 and Dwingeloo 2. Yep. In 2009, the radio telescope was designated as a national monument. So the radio telescope is a radio telescope with a single dish that's with a diameter of 25 meters. The telescope was built in collaboration with various Dutch universities. Dutch, is not German. In 1954 by Workspoor and Phillips. After the words, "Would you press this button, Your Majesty?" the telescope was officially inaugurated by Queen Juliana on Tuesday, 17th of April 1956. For a short time, it was the largest radio telescope in the world. I don't know why I find that hard to believe, but anyway, it's probably correct. So for a short time, and I stress short time, it was the largest radio telescope in the world. The costs of construction were initially estimated at 1.9 million it's equivalent to 1.9 million in 2019. I think that's euro too. Anyway, it doesn't matter about that. The construction of the telescope was funded by then Organisation for Pure Scientific Research. Most of the Astron staff also work at the location of the Dwingeloo Radio Telescope on the edge of the national park. Among other things, they are working on development of hardware and software for the LOFAR telescope. All right, that's just a brief rundown. But what I was aiming to mention was that the dish was set up as a transmitter, and it on the 22nd of March 2025 they say here that we used the Dwingeloo telescope for the first time to bounce a radio signal off the surface of Venus. At that time, Venus was at its closest point to Earth, about 42 million kilometres. The Earth-Venus-Earth reflections were used in the 1960s and 70s to create radar images of Venus. More recently, in 2012, the Arecibo telescope and the Green Bank telescope were used to create a detailed map of Venus. The first and so far only amateur EVE connection was made in 2009 by AMSAT-DL with the 20-metre telescope at Sternwart in Bochum. With the Dwingaloo telescope, we sent tones of 278 seconds long on a frequency of 1299.5 megahertz. Since the light travel time to Venus and back was about 280 seconds, we could then hear the reflection of our own signal. We repeated this cycle 4 times. While the Dwingaloo received its own echo, the Stockart radio telescope operated by Astronomical Stockart also received the Venus echoes of the signal from the Dwingaloo telescope. The echoes received in Stockart were slightly stronger than those in the Dwingaloo because the reception chain in Stockart is slightly more sensitive. A first analysis shows, and actually before I carry on, there is a picture here of the dish. Let me just bring up that quickly. Oops, going to the wrong area. Here's what the telescope looks like. So they say that a first analysis shows a detection of 5.4 sigma for the Dwingaloo Venus Dwingaloo, a detection of 8.5 sigma for Dwingaloo Venus Stockart, and a detection of 9.2 sigma for the compressed signal of Dwingaloo and Stockart. And that's actually these 3 images here, which I shall just bring up. That's what that's referring to. This guy here. So one's the reflected signal from the Dwingaloo telescope, one's from Stockart telescope, and then the others are the combined resultant signal of the two setups, 2 receiving stations. Okay, so going back to the article, it's only got a couple more paragraphs. We also plan to send complex modulated signals to perform more analysis on the signals sent and received. Unfortunately, the transmitter, which had been mounted at the focus box of the Dwingaloo telescope for the occasion, failed after 4 successful echoes. We will postpone the other experiments until next Venus conjunction in October 2026. In preparing for this experiment, we collaborated with the Deep Space Exploration Society, who also prepared their own EVE experiment, and the Open Research Institute. During the day of the experiment, many CAMRAS volunteers, CAMRAS volunteers contributed. So they say here, our thanks go to the volunteers of the Astronomical telescope for the observation with the Stockart telescope. There is a technical paper about the experiment, and data reduction is still being made. I think that's about all I can say on that. But it's interesting to note that with our own radio telescope up at the Leon Mao Dark Sky site, all right, it's physically a smaller dish, 8.5 meters compared to a 25 meter dish. That's an advantage there, or a disadvantage, depending on which way you look at it. But when I was promoting the 8.5 dish telescope many years ago in the various presentations I did, one of the key things that I was planning on doing with the radio telescope, just on the off chance, was to reflect a signal off Venus. And I had no idea about anybody else attempting such things at the time. I just figured that we'd work out when Venus was at its closest approach to Earth to shorten the distance down, and then put a fairly decent transmitter up at the focal point of the at the dish, and simply using Whisper software programs, weak signal programs, making an attempt to see if we could reflect a signal off Venus. And I'm pretty sure that even though with an 8.5 meter dish with the appropriate sensitive front ends and the appropriate weak signal software running, I think there's a possibility of being able to see a very fine line in the waterfall, and that's all I'd be interested in seeing, is the return signal with the fine line in the waterfall, and that's champagne opening bottle stuff. Anyway, just thought I'd say that. Now there is a little video here that I can run of this telescope, which is it's just this one here. So let me just run this. It only goes for 2 minutes. The accent is a bit thick, but listen carefully. Again, you can catch up. The video is on my YouTube stream, VK3CSJ, on my YouTube stream 20 seconds later. Or if you're lucky enough, you'll be watching on my Discord channel. So stand by for this video. This is VK3CSJ. This is courtesy of the Dwingelo Observatory. Stand by.
Above South America, a weak spot in Earth's magnetic field is evolving. Called the South Atlantic.
That's the wrong video. That was another article which I'm about to play as well. Where's my video on Dwingelo? It is there, isn't it? Yeah, there it is. Sorry, here it is. Okay, stand by for it. Here we go again.
In 1956, Astron officially took the Dwingelo radio telescope into use. For a time, it was the largest movable radio telescope in the world. And although Astron currently no longer uses the telescope to acquire scientific data, the 25-meter dish has provided the Netherlands Institute for Radio Astronomy with many scientific data and insights throughout the years. Around the 50s of the previous century, pioneering radio astronomer Jan Oort really wished for a large dish to observe the 21 centimeter hydrogen line of our galaxy. With such a telescope, he would be able to observe the distribution of neutral hydrogen in our own Milky Way. He came up with an idea to make this 25-meter dish, which is covered by chicken wire and therefore also called the chicken wire telescope. In 1954, construction started with NWO, the Dutch Organization for Science, together with Astron. Once the dish was built, astronomers started to use it, and they found they analyzed the movement and structure of the Milky Way. They were particularly interested in the core area of the Milky Way, where the gas made a very erratic movement. Through their observations, astronomers found a spiral arm in the inner part of our Milky Way, which was moving outward. They also found a gas cloud above our Milky Way, which moved with great velocity towards us. At first, astronomers thought that the movements that they found had an explosive origin. But later, these ideas were adjusted. The findings from this telescope shocked the scientific world. The telescope was designed to observe at a frequency of 1420 MHz, or 21 centimeter, and this is the frequency at which hydrogen has a spin-flip transition. However, the first observations with this telescope were performed at 75 centimeters, or a frequency of 400 MHz. At that frequency, the Crab Nebula was observed. Observations with the Dwingelo radio telescope produced a first catalogue of discrete sources. It also produced a map of the magnetic field of our Milky Way. Let's take a look inside. At the time that the dish was built, computers were too slow to convert galactic coordinates into coordinates on Earth. Therefore, an analog computer was built, called the Pilot. Using the Pilot, astronomers could point the telescope at any position in the sky that they wished to study. During its lifetime, the Dwingelo radio telescope was upgraded several times. In 1966, a construction of a new telescope started, called the Westerbork Synthesis Radio Telescope. Even though that this telescope was finished in 1970 and was way more sensitive than the Dwingelo radio telescope, the Dwingelo radio telescope remained an important instrument for science.
One of these breakthroughs is the discovery of a new galaxy behind the Milky Way in 1994 by René Kraan-Korteweg, at that time a KNAW Fellow at the Kaptein Institute of the University of Groningen.
Through thorough analysis of radio waves, astronomers can discriminate between radio waves approaching from nearby, relatively speaking, and from further away. With the radio waves of the Milky Way mapped, astronomers were able to penetrate the dense curtain of gas and dust in the Milky Way, something that an optical telescope cannot achieve. By doing so, Kraan-Korteweg found a new galaxy behind the Milky Way. She named the galaxy Dwingelo 1. One of the two satellite systems of this galaxy is named Dwingelo 2.
During that same year, Dab Hartman made his sensitive all-sky survey of the 21 cm line radiation.
In 1998, the telescope was put in the so-called storm mode, which it didn't come out of until 2007, the year in which CAMRAS was founded, and was given management over the telescope. It remains, however, the property of Astron. The telescope, which is now a national monument, underwent a thorough restoration in 2012 and 2013 and is currently being used by CAMRAS for educational purposes and amateur radio astronomy. And that is how the Dwingelo radio telescope served and to this day continues to serve the Astronomy Society.
All right. Thanks to the Dwingelo Observatory for that little virtual tour of the telescope there, and that was quite interesting. But unfortunately, his accent is a little thick, so it helps to be watching the vision at the same time to get a bit of an idea of what's going on. You're tuned to ASV Radio VK3 Echo Kilo Hotel. So yeah, I congratulate the guys out there at the Dwingelo Observatory for their attempt at reflecting a signal of Venus. They bet us to it anyway, but it still would be interesting to see whether the 8.5 meter dish with the appropriate arrangement set up we could do a similar thing. Anyway, that's another story. All right, now I know that we're coming up to 11 o'clock. My next little article was going to be, let me see, oh yeah, there is a video associated with this too, which you did see very quickly. I might leave that one until next week. Just checking on what there is here. All right, I'll go with this one. NASA is watching a huge growing anomaly in the Earth's magnetic field. Now, I have mentioned this before in previous articles over the few years. I'll bring up the... where's the picture of that? There's a picture of that. Just a sec. I know it's there. that's it. Didn't bring it across. Okay, this is what we're talking about. That red area. So NASA's been monitoring a strange anomaly in the Earth's magnetic field, a giant region of low magnetic intensity in the skies above the planet, stretching out between the South America and Southwest Africa region. This fast developing phenomenon called the South Atlantic Anomaly has intrigued and concerned scientists for years, and perhaps none more so than NASA researchers. The space agency's satellites and spacecraft are particularly vulnerable to the weakened magnetic field strength within the anomaly, and resulting exposure exposure to charged particles from the sun. The South Atlantic Anomaly, or the SAA, likened by NASA to a dent in the Earth's magnetic field, or a kind of pothole in space, generally doesn't affect life on Earth. But the same can't be said for orbital spacecraft, including the International Space Station, which passes directly through the anomaly as they loop around the planet at low Earth orbits altitudes. During these encounters, the reduced magnetic field strength inside the anomaly means that technology systems on board satellites can short circuit and malfunction if they become stuck by high energy protons emanating from the sun. These random hits may usually only produce low-level glitches, but they do carry the risk of causing significant data loss or even permanent damage to key components, threats obliging satellite operators to routinely shut down spacecraft systems before spacecraft enter the anomaly zone. Mitigating those hazards in space is one reason NASA is tracking the SAA. Another is that the mystery of the anomaly represents a great opportunity to investigate a complex and difficult to understand phenomenon. And NASA's broad resources and research groups are uniquely well appointed to study the occurrence. The magnetic field is actually a superposition of fields from many current sources. Geophysicist Terry Sabaka from NASA's Goddard Space Flight Center in Greenbelt, Maryland, explained in the year 2020. The prime source, or the primary source, is considered to be a swirling ocean of molten iron inside the Earth's outer core, thousands of kilometers below the ground. The movement of the mass generates special currents that create Earth's magnetic field, but not necessarily uniformly, it seems. A huge reservoir of dense rock called the African Large Slow Shear Velocity Province, located about 2,900 kilometers below the African continent, is thought to disturb the field's generation, resulting in the dramatic weakening effect, which is aided by the tilt of the planet's magnetic axis. The observed SAA can also interpreted as a consequence of weakening dominance of the dipole field in the region, said NASA's Goddard geophysicist mathematician Wee Jia-kyung in 2020. More specifically, a localized field with reversed polarity grows strongly in the SAA region, thus making the field intensity very weak, weaker than that of the surrounding regions. And here is another graphic that I can bring up in relation to this. So this is actually satellite data that suggests that the SAA is dividing. While there's much scientists still don't fully understand about the anomaly and its implications, new insights are continually shedding light on the strange phenomenon. For example, one study led by NASA's heliophysicist Ashley Greeley in 2016 revealed that the SAA slowly drifts around, which was confirmed by subsequent tracking from CubeSats in research published in 2021. It's not just moving, however. Even more remarkably, the phenomenon seems to be in the process of splitting in two, with researchers in 2020 discovering that the SAA appeared to be dividing into two distinct cells, each representing a separate centre of minimum magnetic intensity within the greater anomaly. Just what that means for the future of the SAA remains unknown, but in any case, there's evidence to suggest that the anomaly is not a new appearance. A study published in July 2020 suggested the phenomenon is not a freak event of recent times, but a recurrent magnetic event that may have affected Earth since as far back as 11 million years ago. If so, that could signal the South Atlantic anomaly is not a trigger or precursor to the entire planet's magnetic field flipping, which is something that actually happens, if not for hundreds or thousands of years at a time. A more recent study published in 2024 found the SAA also has an impact on auroras seen on Earth. Obviously, huge questions remain, but with so much going on with the vast magnetic oddity, it's good to know that the world's most powerful space agency is watching it closely, as they are. Even though the SAA is slowly moving, it is going through some change in morphology, so it's also important that we keep observing it by having continued missions, because that's what helps us make models and predictions, they reckon. So, yeah, so that's an interesting one. And there is a short video on this, and I did start to play that before. Let me just see if I can cue that up again. Yeah, it only goes for 2 minutes. So let me just play this short video by NASA. Stand by.
Above South America, a weak spot in Earth's magnetic field is evolving. Called the South Atlantic Anomaly, this unique region has been expanding for more than a decade, and scientists believe that it's beginning to split into two distinct zones. Now, while this anomaly poses little risk to life here on Earth, it does allow scientists to study the complicated mechanisms behind Earth's magnetism. Around 1,800 miles below the surface, dynamic processes in Earth's liquid iron outer core are continuously generating electrical currents. This accounts for the majority of Earth's magnetic field. But unlike a typical bar magnet with one north and south pole, Earth's magnetism isn't all neat and tidy. If we take a look below the anomaly at the boundaries separating the core and the mantle, we can see the magnetic variations are much stronger. This picture provides a clear link between the anomaly we see in Earth's magnetosphere, its origins deep within Earth's interior, and how it's projected to evolve in the near future. This is important to understand because our planet's magnetic field plays a huge role in shaping the near-Earth environment. In addition to guiding compasses and animal migrations, the magnetic field acts like a shield, repelling charged particles flung from the sun that could be disruptive if they reach the surface. Many of the particles that do slip inside Earth's protective bubble become trapped in large rings of energetic particles called the Van Allen belts, which are held in place by Earth's magnetic field. The inner edge of the innermost belt is about 400 miles from the surface of the Earth at the equator, which keeps particle radiation a safe distance from Earth and orbiting satellites. But because of the offset between Earth's magnetic and rotational poles, and the weakened magnetic field over the South Atlantic anomaly, some energetic particles within the belts do penetrate closer to the Earth's surface. This means that NASA and other space agencies need to account for the extra radiation when low-orbit satellites pass through the anomaly. Currently, NASA researchers are using data from satellites along with theoretical models to track the evolution of the South Atlantic anomaly and help prepare for future challenges to managing satellites and humans in space.
thank you to NASA for that little bit of interest footage. So excellent stuff. All right, so we'll keep an eye on that the anomaly and report back to you guys from time to time how it's going. All right, now just quickly, spaceweather.com. There was no report from Tamatha, so we shall just go straight into spaceweather.com. And the current sunspot activity on our sun, if we could see it right now, is looking a bit like that. The solar wind is currently at 517.5 kilometers a second at a density of 14.41 protons per cubic centimeter. And as you can see, this is the disk of the sun with a smattering of sunspots. Not a whole lot, but there's a few there. The sunspot number is currently 124. The radio sun solar flux is 178 solar flux units, measured at a wavelength of 10.7. The current auroral glow over the Antarctica is looking like that. So there is a little bit of auroral activity going on. And the corona, there's no coronal holes in the sun at the moment. That's the way the sun looks. So there's that much there. And what else? KP index, for those interested in that. The planetary K index is currently 4, which is considered unsettled. And over the next 24 hours, the KP is expected to increase to 4.67 and is also considered as unsettled. Space Weather reports that there is a geomagnetic storm watch. NOAA forecasters say that a minor G1 class geomagnetic storms are likely on April the 4th and 5th due to the effects of the co-rotating interaction region, CIR. CIRs are transition zones between fast and slow-moving streams of solar wind. They contain shock waves akin to those of CMEs and often do a good job at sparking high-altitude auroras. There's a little bit more there on spaceweather.com, but it's not quite relevant to things, so we'll leave it at that. On the 4th of April 2025, there were 2,349 potentially hazardous asteroids, but none of the asteroids are on a collision course with Earth. So I think that's about it in a nutshell. So I think we'll finish up there at 5 past the hour. Some of the articles that I've skipped over tonight to do with the Lagrangian points. What are Lagrangian points? I was going to have a quick discussion about that. And also that the James Webb Space Telescope finds a spiral galaxy about 5 times more massive than the Milky Way. And scientists are calling it the Big Wheel. It existed just 2 billion years after the Big Bang. So there's a pretty fuzzy looking image there, but anyway, it's a spiral galaxy 5 times more massive than the Milky Way, and they're calling it the Big Wheel. Anyway, we'll report on that next week. All right, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria. We shall now open up the frequency for any stations that wish to call in for a quick callback. And we'll see how we go. I've got the headphones stuck in there, haven't I? So I'll just unplug that and turn the volume up, and I think I'll be ready. So this is VK3 EKH listening on 3541 kilohertz.
VK3 VK3SPX. VK3 Zulu Tango.
Oh, that's a good signal.
VK3 Charlie Alpha Hotel.
It's Andrew. All right, VK3GL, VK3HK, VK3SBX, VK3ZT, VK3CAH. Anybody else? All right, VK3WRA, was it? Sorry, VK1WRA. Yeah, I think I got that right. I'll get to you a little later, in a second or two. All right. Yep, all right. I think we've got our blue moon light. All right, standby stations. VK3GL, Graham in Bunyip, VK3EKH.
Okay, very good there, Clint. VK3EKH in the group. VK3GL, very good evening to everyone who's checked in on the check-in session this evening. Heard all of you call in, and Clint, your signal tonight is at 20 over 9. It's been very consistent, lovely audio and etc. this evening. So all copied 100%. Thanks for the broadcast. I listened to quite a fair chunk of it tonight. I was busy earlier in the evening work-wise, and fortunately the last hour or so has been relatively quiet with a few interruptions, but generally okay. So I noted everything that was spoken about tonight. Of some particular interest was the comment about reflecting the signal off Venus. That'd be nice to do. It reminded me of doing some moon bounce on HF when we were operational a few years ago, just before COVID kicked in, and we activated the shortwave radio station, Radio Australia, up there in Shepparton, and we were using one of the curtain arrays, and there was a full moon that came up a particular night, and we did some signal reflection on 21 megs off the moon using the antenna arrays at Radio Australia. So that was quite interesting stuff. So you can understand doing it on VHF or UHF, but certainly on HF getting that reflection. Anyway, all very good, Clint. I'll pass it back to you. You can kick it around the rest of the guys who checked in tonight. But thanks again for being there tonight. You sounded very much normal yourself tonight, so I don't think that there was any issue or any remnants of the influenza that you had earlier in the week. You sounded quite good. VK3EKH, VK3GL.
Yeah, thanks, Gray. VK3GL, VK3 EKH returning. Oh no, it's there. I can tell. I'm still very nasally. It hasn't quite totally cleared, but hopefully by next Friday it should. Yeah, I remember that episode up there at Shepparton. It would have been nice to have actually been up there to look over their shoulders on that one. But most interesting indeed, isn't it? Yeah, when you've got the antenna capability behind you. It's all in the antennas. That's what it's all about. The antennas, you can have a lesser transmitter, but it's the antennas that does all the work. Anyway, thanks, Graham, and thank you for the report. You're also about 20-25 over 9, so not a bad signal. Steve, VK3 Hotel Kilo, VK3 EKH. Go ahead, old man.
Okay, Clint. Yes, very good evening too, and good evening to all the others on frequency. Surprised to hear you there, Andy, but very good evening to you. Yeah, most interesting transmission tonight. Broadcast, very interesting, especially this big wheel thing. I'll be waiting for next week. to find out a little bit more about the big wheel. I'm looking at you on YouTube, so we're a little bit behind the time as far as video is concerned, but YouTube's coming through quite well too. You're hitting 30 dB over 9 here, Clint. It's a hell of a big signal. And yes, the nasal business, it's not quite as bad, nowhere near as bad actually as a week ago, so obviously being back at work has helped you. So, more work, less play. Anyway, back to you. Stop mucking around. VK3EKH. This is VK3HK.
Yeah, thanks, Steve. VK3HK, VK3EKH, returning good signal from you too, mightily strong. Propagation is good tonight on 80 metres, and the band noise is not so bad as well, which is good. Yeah, I haven't been able to listen to the Coffee Break Net the last couple of days, although I did yesterday, but not today. I was in a different part of the factory learning another product, so it was a little bit difficult to be listening to the 160 metre chatter in my left ear and concentrate on other things. So if you don't see me in the Paul's SDR listing, I'm unfortunately not around to be able to monitor you guys with your 11 o'clock banter. Anyway, we'll try and be there tomorrow morning. Meanwhile, thanks, Steve. And yes, I did show the big wheel just a moment ago. It's a very fuzzy looking image, but the big wheel image is just on the screen there. I just put it up again very momentarily. All right, I think that was about it. Thank you for listening. Steve, VK3SBX, VK3, I keep wanting to say CSJ, VK3SBX, VK3EKH.
VK3EKH, this is VK3SBX. G'day, Clint. Yes. Yeah, good stuff as usual. I thought the interesting, I thought the information about the Dwingaloo telescopes were quite interesting, and their quite old film there was quite interesting. And I was just having a little bit of a Google on that as well, and I see they've quite successfully got Voyager signals as well on that telescope, Clint. I don't know whether that would be beyond the 8.5 metre telescope. I was surprised that you could get Voyager signals on a 25 metre telescope. I'm not exactly sure how long ago that was, but there's food for thought there maybe. And yeah, just want to remind everybody, the Bendigo Club is holding their Tech Fest on the 4th of May, following the WIAGM on the 3rd of May. And yeah, you mentioned the ISS before, of course, as you usually do, and we're hoping for an ISS contact during the WIA AGM dinner, I believe. So that'll be an organised event through a repeater somewhere else where the ISS is visible at that time. Anyway, that should be fun. Right, thanks, Clint. Probably see you again next week. VK3EKH, this is VK3SPX.
Yeah, good on you, Steve. VK3SPX, VK3EKH. Yeah, look, I'm fairly impressed with the history of this telescope. To look at it, it's well, yeah, it's 25 meters, so that's a much larger collecting area than 8.5 meter dish. In fact, going by eye, I would say that where the I think there's four support arms for the focal point, where the four supporting arms are mounted to the dish, that would be about roughly 8 meters, 9 meter point, I would say, roughly. So I would say that our 8.5 meter dish would fall within that diameter of those four supporting arms. So that just gives you a bit of that just roughly thinking, that would give you a bit of an idea of the difference. But it's interesting because the way the focal point looks with all the equipment up there at the focal point, that's almost a mirror image of what it looks like up at Heathcote. All our receiver equipment is located at the focal point of the dish, and it's almost, as you see it there in that picture, it's almost exactly the same sort of configuration. So there is a bit of a similarity going on there. No, look, I still think, given weak signal technology, weak signal programs, the whisper program modes and all that sort of stuff, I think it's still possible to see a very, very faint return, and that's all we're achieving, or hoping to achieve, or somebody at least, up there at Heathcote, a very faint return. At the appropriate time. So yeah. Anyway, it may or may not happen. I don't know. All right, just as an update too, Steve. I've just recently, in fact, this week, I got a builder to come out and get the deck straightened out down the back corner. So the deck, the astronomical deck, has now been flattened out. It's now flat as a pancake. I've got a 2 metre long spirit level, and I've gone around all corners, and the little bubble is sitting absolutely smack dab in the middle. This builder bloke, he had a laser device, and he placed that on the concrete pillar in the middle of the deck, and he used that to help level the deck. So we got rid of all the old merbau, and we've now covered the frame with composite decking material, so it looks absolutely brand new, flat as, it's stable to walk on, and so the deck is ready. The deck is complete, and I've sent an email off to Paul at Side Eagle Trading. I'm just waiting for a reply from him. I haven't had a reply yet, but I've sent an email off to Paul to say the deck is ready. So if you want to send somebody out to check for themselves that it's level enough, let's get the 3 metre scope dome finally assembled. So until I hear back from Paul about when that can possibly happen, I would say that within the next month or so, depending on the schedule of the guys, we'll have our 3 metre scope dome finally up and running. So it's getting a little closer. That's just a little bit of an update there for you, Steve. All right. On that note, we go across to Mitch, VK3ZT, and I note a mightily good signal coming in. Mitch, you sounded very good. VK3ZT with a slightly repositioned antenna. This is VK3EKH.
Good evening, Clint and everybody on air. VK3EKH and Greg, VK3ZT. I'd be interested in a signal report. In the past, I've always been a noisy one for you. It's your local noise. A comment. Everybody I've received here is S10 or above. Who was it? VK3HK. I'm sorry, I missed the name, but you're 20 over. And the same for yourself, Clint. Down here to Dalston, you Daggy, 20 over. Lovely audio too. I enjoyed the broadcast and what's the word? The conjunction with the video footage, and I think I've got some RF coming into my headphones. But I hope that's not coming over the audio that you're hearing. Thank you very much, Clint. I'll go back to listening. But again, thank you. I really enjoyed it. Been away for too long, and with the ADM antenna in the wrong position. VK3EKH, VK3ZT.
Good on you, Mitch. VK3ZT, VK3EKH. Very good signal. It's the best. It's the best that I've heard from you in a long time. But according to my Pro 3 meter, you're hovering around 10 to 15 over 9. A little bit of QSB. But that's it. It's 10 to 15 over 9, quite good and reasonable audio, and quite a good acceptable signal coming up here tonight, Mitch. So, like I say, it's the best I've ever heard you. So, congratulations on getting your antenna in a slightly usable and better position, because it's working for you by the sounds of it. So, don't touch it. No, good on you, Mitch. Good, and thank you for kindly for the report on tonight's broadcast. That's excellent stuff. Always try to make the articles varied and of interest. So the hour goes past very, very quickly. It doesn't take long before 60 minutes is up. Thanks, Mitch. Andrew, VK3CAH. If you're still there, VK3EKH.
Good evening. Clint, VK3EKH, VK3 Charlie Alpha Hotel. Broadcast received pretty good. I was doing a couple other things fiddling around here that had that going on in the background, so I did look at the YouTube channel. But seriously, I went to the luncheon at Galstonwick last Thursday, and I had no idea about the Radio Australia site being used for moon bounce. And, during the day, it was the 15-metre antenna was beamed for HF into North America. But on the night time, it went straight through the ionosphere and bounced signals off the moon. It's really interesting, that. There's a lot more that goes on than we realised. But no, all signals from all stations so far, so very good. And I'll pass it back to you, and thanks very much for the broadcast and your efforts there, Clint. VK3EKH, VK3 Charlie Alpha Hotel.
Yeah, good on you, Andrew. VK3 Charlie Alpha Hotel, VK3 EKH replying. Very good. Good to hear you. Good signal from you too, Andrew. Excellent coming up there from the peninsula. Frankston, I think, isn't it? Mount Eliza? I'm not sure. Anyway, and note that this is the weekend of the Old Timers News Bulletin too, which I'll be broadcasting Sunday morning, and again on the A2V repeater at 10:30. So it'll be a full 1 hour on 1825 at 9 o'clock, with the incorporating the WIA news. Yeah, look, I'm still working at the moment, Andrew, so I'm not able to get along to the RAOTC luncheons, but I know there was a good contingency from the coffee break boys on the 11 o'clock. They all took off for the luncheon and enjoyed the presentation by Nigel. So I'm just waiting for the presentation to show up on the website. I'm every couple of days I'm refreshing to see if the presentation's been uploaded yet. If it was in fact recorded, I'm not sure, but looking forward to it anyway. And I know that there was a video taken of that attempt to reflect a signal off the moon when there was access to the Shepparton Radio Australia arrays. If I can locate that video, I'll send you the link so you can look at it and check it out. But there was some sort of video footage taken of that particular test that was done when it was just a one-off. I think it was just one weekend chance to use the Radio Australia arrays at Shepparton before that was all changed. Anyway, I'll see if I can find that video and I'll let you know for sure. Thanks, Andrew. Wayne, VK1WRK, I think it was. VK1WRK. This is VK3EKH.
VK1WRK. Well done there, Clint. I only get a chance to call in from time to time. You did very well there. I've got you guys into Canberra at the moment. A little bit of interference there in the background.
Yeah, thanks, Wayne. You're about 5x8, 4.5 to 8, about strength 8, peaking around strength 8. My noise floor is... Yeah, it's hovering around strength 7 at the moment with lightning crashes. There are actually quite a few lightning crashes there too. But yep, no worries, Wayne. We got you, and thank you very much for calling in. I think you said there was a little bit of interference you've got up there, so yeah, it's always a bit of a hassle. That it's good to see that my YouTube is hanging in. Normally, when I start the callback, my internet streaming falls over, but it's hanging in. So I'm glad to see that. For all the stations that have called in tonight, I'm also piping the audio. Your audios are all going up to the YouTube stream. So once I stop streaming tonight, if you want to check your audio into the station here, just fast forward all the other stuff and go to the callback towards the end of the broadcast, and you'll be able to hear your signal, how it's being copied here on my receiver. So to Mitch for K3ZT, probably a good idea, Mitch, if you want to hear how well you're actually being heard here tonight, you can just do that. Just replay the YouTube video, and that's what's good about YouTube, is that it records the session here. Where unlike Discord, it doesn't record. Discord's just free to air. Anyway, all right. Is there any other stations wishing to check in before we disappear? VK3 EKH listening.
VK3 AOB, just to say g'day.
G'day, Brett. G'day to you, mate. Thanks for calling in. You are in the logbook, as they say.
Yeah, Roger, I did listen most of the night. Had a couple of things I had to wander around the house, but sort of a little bit in earshot. I finally found your live feed vision on the computer, and then you then closed down, as it were. So anyway, it's not a big deal. Nice signal. You're 5x9 plus 30 barefoot here, and I put the preamps on. I get you another 30 dB. 5x9 plus 45 dB. Anyway, it sounds reasonably good. Right, there you go. Got nothing much else to add, so I'll let you go to bed. VK3 EKH and the little group VK3 AOB. Roll boozer. I resemble that remark. I should think so.
Was that resemble or resent? Oh dear. All right, no worries, Brett. Yeah, you're a good solid 20 plus over 9 here tonight. So your always a mightily good signal coming in from up north. So you're doing very, very, very well indeed. Good audio too. No question about that. Yeah, look, the stream bounced back. When I first started the transmission tonight, the RF got into the modem and upset it. And then it was right at the start there. So if you had gone looking again for the YouTube stream, you would have found another live indication. And so the YouTube stream's been running all the way through. It's still there actually. So like I say, as soon as I drop off here and close the stream down, you're more than welcome to go back over it, so you can see all the interesting graphics and the video from the various video information things as well, whatever. Anyway, all right, I'm out of here. Thanks very much, ladies and gentlemen, for tuning into tonight's session, and hopefully we'll be here next Friday to do it all again. I don't think I'll come down with influenza A, or maybe influenza B, perhaps, I don't know, but hopefully not. I never had the flu, so I guess my flu shot has come to good fruition for me this time around, because it only lasted for a few days. Anyway, on that note, this is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, concluding transmission here on 3541 kilohertz and everywhere else. And everybody have a lovely weekend. Look after yourselves, and we'll see you all next Friday. Stay warm, I suppose. It's distinctly, what is it? It's 15.9 degrees here at Narre South as we speak. Cheers everyone, take care. This is VK3 EKH with VK3 CSJ on the microphone concluding.
Yes, good night all. Have a good weekend. VK3 AOB going that way. Horizontally polarised very, very shortly, like the rest of us.
No worries, Steve. Catch you tomorrow if you're about. Come up and give us a bit of slow scan.
As a matter of fact, I've been popping slow scan on during the week. I even resorted to a 20-metre transmission at one stage. I could zoom a picture over in America, but nothing happening here at all.
Yeah, it seems to be dead during the day. And I play around on AREG, and of course the 40-metre signals, the MMSS TV signals aren't being decoded. There's a fault in it.